Hello students, today we will see what is the different types of very high frequency, ultra high frequency, short high frequency antennas. So the very high frequency basically that should be 30 to 300 megahertz, ultra high frequency 300 to 3000 megahertz, and short high frequency is 3000 to 30,000 megahertz respectively. So what will be the wavelength? So wavelength of this antenna is in terms of meter, that is 10 to 1 meter, 1 to 0.1 meters, and 10 centimeter to 1 centimeters. So today we will see what is a dipole antenna. This is a basic antenna which will be used in a TV application as well as the radio application. So dipole antenna basically it has a two poles. So here this is the structure of dipole antenna. So this is a one pole and this will be another pole. For these two poles we have to give the AC signal. So in order to apply the AC signal, this antenna will radiate the signals. So what will be the frequency of dipole antenna? That frequency of a dipole antenna that should be vary from 3 kilo to 300 gigahertz, depends on the requirement of signals. So here why we will call this one as a dipole. So this one is a one pole and this one will be the another pole. If this is a single pole is there, so we will call this one as a monopole antenna. So how we will find out the dipole antenna has a wavelength of lambda by 2. Lambda, that is wavelength in terms of meters. So this particular distance is quarter wavelength, that is 1/4, and this distance is again 1/4 wavelength. So 1/4 plus 1/4, that should be the half wavelength of antenna is there. So after applying the AC signal, this antenna will radiate the electromagnetic signals. So we will see how the waveform for current and voltage will look like. So here I have to apply the AC signals. After applying the AC signal, the current distribution is like this one and the voltage will be flow like this one from the antenna. So this is the waveform for current and voltage. After this we will see the radiation pattern of antenna. After applying the here AC signal for this antenna, it will radiate like this one. So this is for one direction, this will be for another direction. So if you rotate this in horizontal direction, you will observe this type of radiation pattern. So here we will call this one as a bidirectional radiation pattern. So what will be the advantage, disadvantage and application of dipole antenna? We will call this one as a simple dipole antenna. Here advantage is what? Reception of balanced signal will be occurred by using this antenna. Receive a particular signal from band of frequency. So band of frequency already we have mentioned that should be very high frequency, that is 30 to 300 megahertz, and receive a particular signal from a band of frequency. So what will be the disadvantage? So disadvantage is what? That should be the displacements. Means we have to mount this antenna on a particular surface. So that first surface will make some sort of disturbance of signals. Again outdoor managements, and what will be the application, that is TV and radio signals. So today we will see, in this lecture we will see what is a simple dipole antenna which has a wavelength of length of lambda by 2. This is a one pole, this will be the another pole. We have to apply the AC signal. So this is 1/4 wavelength, 1/4 length, which will mix to form a half wavelength. Then its voltage waveform for current and voltage, then radiation pattern and advantage, disadvantage and application. Thank you.